Okay, so we're talking about vectors on basically a XY coordinate plane. Maybe I should use graph paper instead. We will need a little bit of graph paper today, but most of this is not. It's just numbers, but I'll use graph paper for a visual here. So, when you put a vector on the plane, you kind of need a starting point. Actually, this isn't just vectors. This is kind of how to do lines with vectors and kind of how it travels over time. So let's say we had one vector that was like 1, 2. And it starts at 2, 2, 1. Well, if you keep stacking those vectors on top of each other, it kind of goes forever like that. And if you go in reverse, it goes like that. Anyway, you can make a line out of it. And if you think of this as like the starting point, 2, 1, how do we get anywhere on this vector? Well, the vectors are all 1, 2 vectors, right? They go 1 to the right and 2 up. And if you just put a variable on that, can move it along this line here. So if t was 1, then you'd have 2, 1 plus 1, 2. You'd have a 3, 3 vector. I guess I should be using that notation. So after t being 1, you're up here at 3, 3. If t is 2, this would be 2, 4. So 2, 1 plus 2, 4 is 4, 5. Okay, it's right there. You guys see what's happening here? Maybe not. Okay, when t is 1, so 2, 1 is my starting point. When t is 1, after 1, you add on the vector, 1, 2. So you're up here at 3, 3. After t is 2, so if you multiply this by 2, you're up here on another vector. It kind of goes back to the last couple of assignments. When you multiply the vector by 2, it's just twice as long. It moves twice as far. So you do 2, 1 plus 2, 4, you get 4, 5. That's where this point is at. Okay, they chose t because you can kind of think of it like time. After 1, whatever, hour, minute, whatever, it's here. After 2, it's here. After 3, it's here. And you can even go backwards in time. If t was negative 1, that would be negative 1, negative 2, which would give you 1, negative 1, which is right here. So if t is negative 1, you go backwards and it goes right there. Does that make sense? You guys don't understand it? Okay. So 2, 1 is the starting point. We got that. What happens when you add a 1, 2 vector onto it? It goes right 1 up 2. So it's right there at 3, 3. That's where that came from. If you add 2 of those to it, it goes all the way up here, 4, 5. Okay, I just multiply this by 2, add it together, 4, 5. Just multiplying and adding. So, but this is what it looks like visually. After t equals 3, you'll be way up here. After t equals 4, you'll be way up here. If you go t equals negative 1, I go back in time, it goes backwards. So you can be anywhere on this line depending on what your t value is. And you don't have to use whole numbers. You could use, or integers. You could use fractions and whatever. You'd be anywhere on this line based on where t is. So this is the starting point. This is kind of the vector that moves it along. T tells you how many vectors you use to move it along. And that gives you a location in space. Okay.
Were you getting the 2, 0 at the bottom?
2, 0.
2, 0. It's not a 2, 0.
It's 2, 1. parentheses is just close to.
I just copied this
Oh.
as a starting point.
It's 0. Okay.
Alright. Anyways. We don't really have to do the graph version until like number 9. Okay, so there's something called a vector equation and a parametric equation. Really, I don't think this assignment's that hard, but you guys can contradict me if you want to. Okay, vector equations. So you can get the xy coordinate anywhere. So first you put the starting, it's kind of like what I was just doing above. You put the starting point. So number 1, it says the line through 1, 5. So we can use 1, 5 as the starting point. Then you put plus t. And then we need the vector that moves the thing. So this book uses parentheses. I don't know, maybe I should use a vector dictation. I guess I'm not going to grade on it, but it says the direction vector is 2, -1. Okay, so the starting point, and then the vector that moves it. That's called the vector equation. It doesn't really matter what you use for the starting point as long as it's on the lines somewhere. You can still get anywhere on this line. The parametric equation is kind of use this. So you just do the x and y coordinates separately. So the x coordinate will basically be 1 plus 2 times t. And the y coordinate is going to be 5 plus -1 times t, or just 5 minus t. So the first thing is the vector equation, the second one is are the parametric equations.
Do you ever have to find what t is?
Well, t could be anything, it's a variable.
Okay.
Did they ask a question like that? I don't think so, no. They could. Yeah, it'd be easy. That's probably why they did that. Okay, let's do number 3 and then I'll go back and talk about number 2 a little bit. So on number 3, it says the line through 1, 0 and 3, -4. So this one's different because they don't give us the vector. But what vector could get us from this point to this point?
2, -4.
Right. Goes back to last week. How do you get from 1 to 3? Move 2 to the right. How do you get from 0 to -4? Move 4 down. So that would be the vector that would move us on this line. And we would need to use one of these as a starting point, so I'm just going to use 1, 0. So the vector equation is 1, 0 plus t, and I think I'm just going to use parentheses even though this is supposed to be a vector. Makes more sense, I guess. What would the parametric equations be?
1 plus 2t.
Yeah. For the x and for the y?
0 minus 4t.
Yeah, now do we need the 0? Probably not, right? So just -4t. t. All right. Number 2, it says the x-intercept is 4. If the x-intercept is 4, what point is that on the graph?
4, 0.
4, 0. And the y-intercept is -3, so that would be
0, -3.
yeah. So you can use those 2 points just like we did on number 3. Find a vector that would move between those 2 points to set it up. Okay, number 5. The horizontal line through -2, 3 and 5, 1. Oh, no, sorry, I was reading the wrong line. The line through -2, 3 and 5, 1. I was gonna say that can't be horizontal to both sides. Okay, so what do we need to do first? We need to find the vector. How can we move from this point to this point? What vector does that? So how do you get from -2 to 5? Okay, now if you're not sure, you remember the other way you could figure it out? 5 minus -2. Yeah, you just do the second x minus the first x, second y minus the first y. But yeah, from -2 to 5, that's increasing by 7. From 3 to 1, it's decreasing by 2. Okay, so that's the vector. So the starting point, we just got to choose one. I just always take the first one. So I'll use -2, 3 plus t, 7, -2. All right, so parametric equations.
-2 plus 17.
Mm-mm. All right. Okay, on number 7 it just says a horizontal line through pi e. So pi e we can use as our starting point. But if we want to move horizontally, what vector could we use? That's vertically. Horizontally looks like the horizon. If we want to move horizontally, what vector could we use to move that way?
+0.
What could this vector be?
2, 0 or something.
Could be 2, 0, yeah. They just use, yeah, like something in the x direction but nothing in the y direction, right? So this one looks like it's about 4, 0. But they just use 1, 0 as, kind of just a basic 1 to the right, 0 up. Okay.
Pi plus t.
Alright, pi plus t and value is constant. It's not gonna go up or down.
Just wait.
Just kick your table. Okay, number 9. Graph the. Okay, this is the graph part. Maybe you guys will get it more after you do it. I think we need that much graph paper.
Maybe video might need a half the whole.
Torture them and make them do it on their time.
I might need a whole paper. No, me too.
Dang it. Never did that very easy.
No. Cute. Probably next time. Your response.
Okay. So in 9 and 10, a point moves in the plane so that its position, point at xy, at time t is given by the specified vector equation. Graph the point's position in times t equals 0, 1, 2, 3, -1, -2, -3. Find the velocity and speed of the moving point. We haven't talked about that yet. And find the parametric equations of the moving point. That's the old part. Okay, so on 9, what is our starting point going to be?
1, 4. Let's go.
So 1, 4. What would the value of t be at this point? Since it's our starting point, that's at time 0. Okay, where are we going to move from there after 1, 4? You'll have to look at the equation to figure it out. If t is 1, where are we going to move?
3. Oh, wait, 3 down to 3.
Right, 3 down 2, yes. So at t equals 1, where will we be? Right, 3 down 2. How far do we have to go? T equals 3. At t equals 2.
Wait, that was only down 1.
Oh, whoops. At t equals 2, right, 3 down 2. T equals 3 on my graph. But we also have to go back to t equals -3 and then the graph bigger. Huh? So if we're going back to, if t is -1, where is this going to go?
That way.
Backwards. Instead of right 3 down 2, it's going to go left 3 up 2. Alright. Makes sense now? It's kind of like, you can think of it like plotting the course of like a, oh shoot, what are those called?
A boat?
No, I was thinking space. Those things that loop around every like couple decades.
Satellite?
Yeah, well, you
Space
could do that too, but
Space station.
They move around all faster
comets, like comets, but that's like satellites. So you could like plot the position of a satellite when after 1 hour, 2 hours, this is where it is. 3 hours, this is where it is. So this kind of just shows you as time passes where the location is. Does that make sense? All right. Got it, Allison? Yep. Okay. Did that make sense? Okay. So you guys can do 10 then, right?
But
Well, that was just A part, actually, the graph.
Let's just do A, and then
Okay, B, what was the B question?
not B.
Okay, the velocity, I don't really like that they asked that. It's basically just the vector that moves it. So when they say velocity, they just mean the vector that moves it. So what was the vector that moved number 9? 3, -2.
That's all that means.
Yes, but they also ask for the speed.
Fast.
What do you think the speed means? Speed is how far are you moving? It's confusing because velocity and speed kind of are like the same thing.
distance
But
from it.
yeah, it means how far are you moving per hour or minute or whatever. So speed would be like how far are we getting in 1
So is this like
t?
3 squared plus -2 squared equals?
Right. It's like Friday. So we can find that distance by doing Pythagorean theorem. 2 squared plus 3 squared equals this squared. So you do 2 squared plus 3 squared and the square root of that.
Oh, square root of 13.
So let's put the velocity or the magnitude symbols. That's how far it's moving in 1 unit of t time. Okay, what was the C question? Oh, parametric equation. This is the easy part, right? Parametric equations. So that was just the x equals y equals version, like where it's separate. So just look at number 9. No, the graph doesn't really help as much. So if you look in the book at number 9, what's the x value going to be?
1 plus 3t.
1 plus 3t. What's the y value going to be?
4 minus 2t.
4 minus 2t. Okay, 11. Velocity is 3, -1. Velocity is basically the vector that moves us. And the position at time t equals 0 is 2, 3. So if t equals 0 is at 2, 3, that means 2, 3 is our starting point. We're supposed to write parametric equation. So we're starting at 2, 3. And the velocity is 3, -1. Easy peasy. Oh, it asks for the parametric too, of course. Okay, 13. A line has vector equation xy equals 3, 2 plus t, 2, 4. Give a parametric equation and equations, plural, there's an x equals and a y equals, and a Cartesian equation of a line. Okay. So, Sebastian, what will the parametric equation be for 13?
3 plus 2t,
And the y?
2 plus 4t.
Okay, what they mean by a Cartesian plane is the xy coordinate plane. So, what do the equations usually look like for that? Well, usually they look like this, right? Except for instead of the t, usually we have an x. So that's what it would look like. They changed it to standard form, but that's okay. That would be the equation for the line.
So just do the y up there.
Wait. Oh, that's not right. Oh. Yeah. Why wouldn't it be right, eh? You tell me the right one. Cause that tells you the y value.